hypothesis and alternative hypothesis. When we conduct a hypothesis test, we will have to choose between two claims, the null hypothesis and the alternative hypothesis. The null hypothesis is the neutral, skeptical statement about a population parameter. In the context of researching new ideas, the null hypothesis often represents no change, no effect, or no difference. It's sort of like the standard. Now, the alternative hypothesis is the research hypothesis. So if you conduct some research and you find something kind of interesting happens, the alternative hypothesis is essentially the statement about the value of the parameter that you got and like whether or not it tells you something about an entire group, or it makes you think that the null hypothesis isn't actually true after all. Okay, so this is kind of abstract, so we will look at a specific example to make it clear. Suppose an experiment is done with criminals released from prison in a certain state where the recidivism rate is 40%. That is, 40% of criminals return to prison within 3 years. 100 random prisoners are made to attend a boot camp for 2 weeks before they're released from prison. And it's hoped that the boot camp will have a good effect. In other words, it'll make it less likely that they return to prison. So we're interested in finding out whether going to boot camp makes it actually less likely that a prisoner will go back to prison. And in other words, if they go to boot camp, will the recidivism rate go down? Will this number be lower than 40%? Okay, so if you were to do a study like this, the null hypothesis is going to be that those attending boot camp have a recidivism rate that was the same as those who did not attend boot camp. So it's the it's sort of like the more skeptical view on this. The skeptic would say, well, I don't think this boot camp will really make a difference. I think that even if the prisoners go to boot camp, we're still going to see the same recidivism rate, or the probability that the prisoners return to prison within 3 years is still 0.40 or 40%. Now, the alternative hypothesis is the less skeptical one. It's the one that we sort of like are hoping to see or we think might happen. And in this case, the alternative hypothesis is that the proportion of criminals who attend boot camp who return to prison is actually less than 0.40. So it's less likely they'll go back to prison if they go to this boot camp. So we have two hypotheses here. And we want to come up with some way to either reject the null hypothesis and go with the alternative hypothesis, or stick with the null hypothesis right here. And that's sort of what we'll do with a hypothesis test in section 8.2. Now, right now we're just focusing on the vocab null hypothesis and alternative hypothesis, and one other thing we need to look at is notation. So we're going to see this special notation, and it's right here. So H naught P equals 0.40. This is sort of like our mathy statistical way of saying that the null hypothesis is P equals 0.40. H naught, or H with the little 0 down here, stands for null hypothesis. P equals 0.40 stands for we think the probability that prisoners who go to boot camp will return to prison is 0.40, the same as if they didn't go to boot camp. Now, for alternative hypothesis, we use this notation H sub A, so it's like an H with a little a down here in the subscript, and that stands for alternative hypothesis. And all our alternative hypothesis here is that P is less than 0.40, or the probability that prisoners who go to boot camp will return to prison is less than 0.40. Okay, so you're going to see these symbols, and this one stands for null hypothesis, this one stands for alternative hypothesis. Now, for hypothesis testing, we can have two-sided, one-sided on the left, or one-sided on the right hypotheses. And we have different notation for each type. For the null hypothesis, you always write P equals P naught, and so it always looks the same for null hypothesis, just like this. And your P naught, that's this one right here. That's always the percentage or proportion. Well, this is actually a proportion always that you see when you do your experiment. So in the example we just did, I'm going to flip back. Sorry, it's not the one you see in your experiment, so scratch that. It's the proportion that you see like just as like a standard or like the skeptical percentage. So in this case, it's 0.40. Now, that's always equal to sign there. Now, the thing that can be vary is the alternative hypothesis. You could have a not equal sign, you could have a less than symbol, or you could have a greater than symbol. And basically, this one, the first one, not equal to, stands for we think that we won't see the same as the null hypothesis in our proportion. We don't know if this is going to be greater than or less than. Now, here the less than symbol is that our alternative hypothesis is that we're going to see a p that's smaller than the null hypothesis proportion, and then over here we're thinking we might see a p that is bigger than the null hypothesis proportion. Now, to make this more clear, let's go to the example again. So in the one that we just did, we had a one-sided hypothesis. I know that because for the alternative hypothesis, we had a less than symbol. It's one-sided if you have a less than or a greater than here. And then we had a less than because we were thinking that the boot camp is going to make it less likely that the prisoner will go back to prison. So we're thinking that this p-value is going to be smaller than the null hypothesis p-value. Okay, now let's compare that to if we had a greater than symbol here. In this case, we would put greater than here if we thought that the boot camp was going to make it more likely that the prisoners go back to prison. Like they somehow hate the boot camp and it's so like it makes them want to commit more crimes, which is, I mean, it doesn't seem very logical within the context of this problem, but if it said boot camp makes it more likely that the prisoner goes back to prison, then we would still have a one-sided hypothesis, but it would be a greater than symbol right here. So we might think that this p would be bigger than the standard. Okay, so those are both one-sided. Now let's look at a two-sided example, and so this is going to be a different one. And so this example says, suppose you flip and observe whether or not you get heads. This is supposed to say flip a coin, sorry about that. And observe whether or not you get heads. The null hypothesis is that the coin is fair. The alternative hypothesis is that the coin is not fair. So our null hypothesis in this case is that you flip the coin and it's fair. In other words, there's a 50% chance that the coin will land on heads. That's sort of like the norm if you have a fair coin. Now, alternative hypothesis is the coin is not fair. In other words, the coin is more likely to land on one-sided versus the other. So it's like not 50-50 chance that it lands on heads versus tails. How do we write that in notation? We would write for the null hypothesis, p is equal to 0.50. That's the chance it will land on heads versus heads. And then for alternative hypothesis, we would put p is not equal to 0.50. We don't know if the coin is more likely to land on heads or less likely to land on heads. We just know that if it's not fair, it would be not equal to 0.50. So this is an example of a two-sided hypothesis. So when you see for the alternative hypothesis a not equal to sign, that's a two-sided hypothesis. Okay, so null hypothesis always gets the benefit of the doubt when you're doing a hypothesis test. So you're going to be very skeptical. You're going to give the null hypothesis the benefit of the doubt. It's assumed to be true throughout the hypothesis testing procedure that we learned in 8.2. If we decide, based on what we do at the last step of our hypothesis test that we have yet to learn, that the observed outcome is extremely unusual under this assumption, then and only then will we reject the null hypothesis. We'll see more of this later.